Hello, my name is Richard Anthony Marca, and this is my EGR402 Capstone Sprint 4 review. So we are going to take a live look at Jira to look at what we did under Sprint 4. And here is a look at our sprint burn down chart. As you can see, due to spring break, we were not probably organized as well as we should have, but we did do a lot of work. So that's why it starts very low over here. But then once we go closer to the due date, we actually added a lot more things to our sprint. And if you see from the burn up report, that this has probably been one of our most consistent sprints to date. With this is a timeline of our entire sprint. And if I go over to the backlog, these are everything that has been completed and not completed in our sprint. Even though I only had one objective for the sprint, it was a very hard and tedious objective, which is why it was worth 12 points. And that was merging my code with Titus's code, which I will explain later. And here is a look at our burn down and burn up charts, where we have 28 completed story points out of the 9 as a group. Things that went well: there were better coordination with the ME and ECE teams. I do have to hand it to Abraham. He did a fantastic job and has definitely put in a lot of work into sprint. The code for all three of us mostly has been integrated together. Now, the rooms for improvement are kind of the same. We do need more coordination, and we need to properly track task progress throughout the sprint and not just at the end, and communicating clearer specifics for goals, which probably was due to spring break being a factor. And this will be the breakdown of our labor. Out of the 12 that I had, I was able to complete all 12, as well as Abraham was able to do everything he needed as well. Now I will show you the actual live demo. Here is the old simulator, which I now moved into Titus's folder because I'm actually implementing everything into his main file. I have this here to help with the merge process. And then I also created a shared folder for a bunch of the helper methods so that it reduces the amount of code inside of main. Even though this has almost 500 lines of code, main still has 1,600 lines of code. But I will start with the top, where I'm using his robot and world imports. So these are his files where the world has a lot of things commented out, which is for the automation, which I have implemented some of that stuff into the actual main file, but also commented out. And the robot, which has some of his, but is also using most of mine. I did edit this robot file so it uses more of the code that I made versus the code that he made, because I was mostly in charge of the robot, with the exceptions of some of the differences like his arcs he has to show the directions. And for the main file, we're going to have, this is for the simulated shared. I organized the import so it looked nicer, kind of like, in an order. And all these imported methods from simulated shared to reduce the workload. So the first major change is, instead of using the keyboard to test the robot, we now use a controller with a joystick, which I do have plugged in. So instead of using the keys, it's going to be using the controller. This is some of the things that are still from the old file. That's the scaling things. So if I go down more, the colors are the same. It's hard to tell which is actually different because technically everything is different, but it's from my simulator file. So this is the path segmentation. You will see the demonstration where there's going to be two blue lines that kind of show where the robot's going to go, which is to help with automation. And this is the logic to create the arcs using the segments. This is a separate, in case, let's just say we forget our controller, we still have the arrow keys that you can use if it does not sense a controller, which it will show on the bottom since like here it did some testing. If it senses the joystick, it's going to use the joystick commands, but if it doesn't sense the joysticks, it's going to stay with the keyboard commands, which will be changed once we input the automated thing, where instead of having it default to keyboard, it's going to default to automation. And even though it says LiDAR, we're actually not using LiDAR. We plan on using ultrasound. These are some of the trail variables from mine. Set robot pose is from robot, so there's going to be a lot of things that are from the robot Python file that Titus made. If I go down, this is for automatic auto mode, which is also going to be updated later. Control state. This is for a new overhead that he used that I actually preferred, so I imported his overhead. More of the stop scaling. Pygame loop. This is for the keep original world import path alive. Titus wanted to keep this in there, so I kept it in here. I know it does not reach anything, it's not accessed, but in his it wasn't accessed either, so I don't know if he wants me to delete it later. This is syncing the robot model from local. This is to make sure it's slower when it's turning, because it was going too fast. This is some of the commented code for the automation. And this is for when the mode driver is mainly for when we apply the automation. This is more the joystick logic. This is for the autonomous state machine. So if automatic is enabled, we have this, but we don't have like what auto is supposed to do because that's implemented. So this else is never to be reached. It's going to be just the first one. This is for the obstacles, but instead of adding obstacles directly, it's going to be sensed via the ultrasound. These are more for the helper functions to help keep the robot centered. These are for the wheel surfaces, which has been shown before. This is for the boundary drawings. This is for the HUD, which is in testing only, which this probably will not even be used because of Abraham is doing more of the HUD for the other parts. The cleaning HUD, control locks. This is to help for the video streaming. And this is commented out because Abraham is planning on hosting a website instead of a local host and is now going to use that website to stream the simulation. Now I'm going to show the actual game. So if I start up the game, you're going to see a very different UI, left and right, obstacle 0. But you're also going to see the mode is driver because I have the controller plugged in, as you can see down in the terminal. The scale is at 1 right now, which this is basically the robot, which is 3x3. So if I start with the left trigger, let's just make a shape like this. Another cool feature is if I go like here, let's just say, I don't have to worry about connecting it because if I stop, it automatically connects. And if I toggle the water, it looks more like a wet surface. It doesn't look as dark. But the speed is still the same as my implemented files. So now it is able to keep the same speed. It's able to turn off the water and turn it back on. And this speed is what the mechanical engineers said was going to be the approximate cleaning speed, is about 0.3 feet a second. And on Abraham's UI, it will have the actual distances so you know that this is being accurate. And if you notice now, due to what I was now told, the caster area is actually where it's supposed to stop. It's actually supposed to go a little bit over the boundaries. So I was able to edit this and fix it so that it actually is going the correct distance from the boundary. So it is supposed to go over slightly. The being kind of like able to go over that much is by design. And now let's take a look at what we plan on for the next sprint. For sprint 5, there's going to be more added later, but for what we have right now, I have to continue with the final merging. So once Abraham gives me his part of the code that's been merged, I will be able to put it into the final main Python file. And just to basic cleanup of code and removing redundancies. For example, some of the methods could be deleted because it's either not going to be used or it is kind of a copy of another. With the addition of making final decisions on what we do plan on having and what we don't have on planning. And that is it for this Sprint 4 review. Thank you, and I will see you in the next one.